Hello everybody, welcome to another stream. So last stream we cleaned up the PBR code, so it's now like not horrible. And then we also made a diagram using the debug rendering that we're going to be putting together. Yes, we're putting together like a devlog basically, so I want to get a bunch of little diagrams that we can use to describe how to, code PBR into your game engine or whatever, I don't know, something like that. So we also added multiple lights. You can tell we've got two light sources now. One moves. What else did we do? We also added the ambient part of the I guess you call it the PBR shading, because that was missing and this was just completely black. So now that's fixed. So yeah, it's pretty dope. Zoom. Zoom. So yeah, we're going to carry on today with making more diagrams and, just make some cool ways of visualizing what's going on under the hood. So this one is actually one of the later ones. This is when we calculate that diffuser radiance map, and I actually might rename it while we're here today as well. Right. I put this code in here because when we debug drew some vectors and they had these NANs or whatever, it would cause some issues. So I want to put them on the sphere right now. Yeah, so S radius if it's NAN or infinity. And then S center position, please. If that's NAN or infinity, then yeah, I hope everyone is doing well. So if we start using that invalid data, sometimes these debug drawings just go crazy. So I just wanted to get these in where it would not allow you to carry on. Right, center position in view space. And the other one is half dims in view space as well. So that's the AABB. There's also an OBB as well. So I think we can do that. Oh, there's a bit of a hum. Hear a hum. Let's move some cables. The baby monitor was the power cable was resting on the microphone lead. Hey Jeffries, how's it going? How can I read this? What's the problem with it? But some of this is just debug code, so it's messy. Like the graphics stuff is the messiest part of the code. The rest is actually quite tidy and clean in comparison. Because we've just been throwing stuff together to see what we can visually achieve. Right, so we have this transform. We decode. And then border thickness. Wait, did we miss a border thickness as well? We did. Oh. Okay, so that's nice and safe now. This one has a border thickness, but it also has this transform. And when do you know about... When do I use the transform? Yeah, I moved the ray. I moved the ray, isn't it? Yeah. So if any of those are infinity or an AN, basically. So we can then bail then. So let's just plop that in there like so. Border thickness as well. Cool. So that means we've now got some nice safety checks. All right. Because if we didn't have those safety checks in there when we did when we drew the vector, the debug draw for the vector, it actually meant that the screen would flicker. It was really weird. So yeah. Right, we lost the box. We've lost the AABB. Oh no, border thickness infinity is a feature. That's a feature. Because if your border is infinity, it means you don't have a border. Alright, the box is back. Sweet. So I like this sort of diagram that we've made, but yeah, maybe we can do some different colors, or should I put some UI up on the right hand side to give a key of like what is what? Or on the right hand side here or something, I don't know. Yeah. I think we can do that. Where's the... So where do we end the UI? Let's find where we do that. Where do we... Right, here's where we do the UI here. So I think what we can do is we can put in this diagram code here, and then we'll be able to use the immediate mode UI and display something like a key or something. I don't know if we will. Yeah, it'll be a bit hard coded, but I think we can do it. I think it's possible. I would have to mix it up with the debug draw stuff, but it's possible. Where is it? Right about there. So in the first diagram, what I would like to do is, right, where's that window rectangle? Perfect. So I think what we can do is say UI cut. So we kind of want to cut to the right. Probably by about 100 or something. I don't know, maybe more. Now produces another rectangle. Let's call this one. Let's call it right side. I don't know. So then we probably want to be able to center, do a center vertically, I guess. So we want to say it's going to be maybe like 500 big. So So now with this, what we can do is we can cut from the top each time, and we're gonna have something on the right hand side, which will be the which should be where the key goes. So we'll just call it A. So for this one, so let's just test it out. Do a bit of text. We'll put in the rectangle A, put in a bit of text. This is, so let's just write cube map. And then we can put like UI, no box style. Right, let's give that a go. Hey there, Anna James, how's it going? Welcome, welcome. How you doing? Right, so see the word cube map there now. It's kind of nice. It's a bit small though, and it does kind of like not. But yeah, so at least we can get some text there, and we can actually give it a background. We can probably just use the. So I have got a 2D draw, which allows us to debug draw. Really, we should, technically you should use like the UI to do this. This is debug drawing stuff, but this is only used to put together a video, so just whatever gets the job done. So UI rec center, UI rec half dims. And I think depth, let's just say 0. Wait a minute. This is drawn on top of the UI. It's always drawn on top of the UI, so I can't really do it then. Yeah, that doesn't work. Yeah, not bad, not bad. Just been busy at work today. But yeah, things are going pretty good. Quite happy where the project is. I managed to get PBR basically finished. So things are looking far better than they were. I think if I can dig out an old screenshot. Yeah, we used to have these guys. So we didn't really have any shading really. Just a bunch of red spheres. So now I've got some proper shading here. I could maybe make it go back to what it was though. Whereas tons of smaller spheres and see what that looks like. Probably something I should look into at some point. But yeah. So just trying to put together a little video now on how some of this stuff works. I'm just thinking like how I want to do that, So in the UI we actually don't have any. I think we can just make a new widget. We can just say UI color, and it just displays a color as a rectangle. It's very easy to do. So it's just literally going to draw a color. I guess there's something else is missing. Says like, descender widget start. Oh, okay. We need a style. Do we need a style? Yeah, I guess you could put it in some box or something. I don't know. Then you're drawing, I guess, a box. So regarding this image draw, how does that work? Here we go. Right, so there'll be a rectangle. That's right. So we just need to say color, UI color solid, throw the color in, and that should be it. Should be everything we need. So now, instead we can actually do a cut left. UI rec b equals UI rec cut left. A, and then we're going to cut maybe, let's say, 40 pixels. And then that's where the new UI color will end up going. So what color are we doing? I think it was cyan. And then I guess we'll do like a no box style. Yeah, so I think that is basically what we want to do repeatedly. Build up like a nice little key or something. Oh, that's way too big. Right, it's in the whole box. That's, yeah. How long have I been programming for? Probably about 14 years now. Something like that. How about you? What sort of projects you're working on? So yeah, it's too bad. It's good. Oh, why is this thing cut right? Let's just say cut top. $200. You only want like probably 20. Cool. So the problem is that it's got a bit of radius on it. It's showing up a bit squished. Not really expecting that. Is there a radius? 16, damn it. Just a bit of radius. Let's try that out. Terminus. I've seen Terminus. Hey, the Hostman. Yeah, I've seen it. Right, there we go. Got a nice blocky thing there now. Now, we should really probably give it a bit of a background, not gonna lie. We can do that as well with the UI draw stuff. So UI draw color solid. Wait. I can just do a box draw. And the box I want to do it on is before we perform the... No, it's just A. Yeah, it'd be what A is here. A. No box style. Ooh. So just give it a bit of a background. And there we go. Cool. It's not... What else do I need with it, really? I don't know why it's so damn close. I thought this would have had a bit of... Right, it's just text, isn't it? Well, I could have just done a UI box. And then... inside the box... Yeah, I would have done the same thing. Well, I would have added a bit better of a... So instead I could do like a... Isn't Terminus that pixel perfect font? So you have to get it the right size, is it? I'm not a programmer in my profession. I'm a digital artist by profession, by passion. That's profession. Awesome. That's cool. That's very nice. I'm glad that you have a something that you do for passion as full time as well. That's what I do as well, and it's really cool. Um, yeah. Have you got any like links to stuff that you've done that you don't mind sharing? So I think I want to do a little bit of an extra cut, just to give it a little bit of margin. Super hacky. But yeah, I think that. Wait. Then A will be the one that you use, and you say cut left. Yeah, I think that's still fine. So we can just keep copying and pasting that and just produce. Right. So it has added a bit of margin and all that, which is great. Now the cut is just not big enough. Make it 40 instead. Nearly there. Getting better. 30. And then we just repeat that for all the different things we want to label. And there we go. Nice. That's great. Let's keep that. Looks kind of cool. So yeah, I probably don't want to trap the I probably want to try and trap the mouse at boot because I keep. Stack trap mouse. Where is this? Wait, true trap mouse. The mouse. Hide. So why is it sort of like starting up in a weird? Right, if trap. Okay, so these don't get initialized then. Yes, the matrix never gets initialized now, which is a bit of an issue. I guess we could say and times seconds. Or 0 seconds. There we go. So now my mouse is locked. Sorry. Now the mouse doesn't sort of get trapped and control the camera at boot. You have to press escape and get in there like that. Cool. Cool. Right. That works for this thing that we're doing here now. Or anything else left to do? I guess we can now focus on like this diagram itself and figure out how I want to improve the looks of this thing. By the way, would you like to take a look at my work? I'd love to share my work with you. Yeah, sure. Yeah, you can share it. You can send me a link now, or you can hop in the Discord and post it in there. There's a Discord link. But yeah, any of those two places is cool. Um, so in terms of the colors, let's make it a little bit more appealing. Where's my color? Core. Yeah, so I think the proportionally everything is fine. We've got a bit of cyan for that box. Could use teal though. Teal is typically nicer than cyan. IBB teal. Why doesn't that work? There's teal. Wait, the problem with this being here is I have chat on the right hand side, so I guess when I record the video I need to minimize chat. Yeah, I gotta be careful of that. Thinking about it now. That is cool though. Why do I not? Why am I seeing? Why am I not seeing something sensible? Let's try try and make it green for a second. Right, okay. This shows up green, but it looks different. And the reason is because it's probably sRGB conversion is off. So let's fix that. So there's a color. Yeah. Yeah, we're done a silly, aren't we? Color unpack. Color unpack. So yeah, it's just unpacks. That's fine. So closest hit color is in sRGB. So what we need to do is before we do anything, linear to sRGB. But it's already in sRGB. So sRGB to linear. Operate on it in linear space, convert it back, do your swizzling, and voila. Right. So if we try that, the color should now look sRGB. Your ray tracing. You been doing ray tracing, husband? Whoa, look at that. Oh. Is this ray marching? Oh, it's metaballs. Nice. Look at that. Jum. I like it. I'm seeing this sort of like soft edge. What are you doing for that? Is that just by nature of doing the metaballs? Looks nice and soft. Hey, Isaac. Oh, Isaac. This is cool, man. Wait, there's controls? Hey. Wait, you're not going? Oh, okay. There you go. Right. I'm using the Colmac keyboard layout, and it's using key codes, not scan codes, but this is cool. I'll refresh that. Then Q and right, it's go up and down, right. These keys are way off because I'm using a different keyboard layout. That's cool. Nice. Very cool. I like it. Very impressed. Ray marching. Right. So regarding the PBR adventure, it's going good. We're working on some diagrams now for the devlog that's coming up. So I've got this little thing here as a key. I'm trying to sort of just sort out the colors. I think the diagram's perfectly fine, and we'll work on some more diagrams. But yeah, so PBR is going good. We added 2 lights yesterday, so we've got twice as many lights now. We fixed out the ambient color here, so there's now like an ambient light coming from the rest of the scene, which is great. I forgot to do that. What else? I think that's about it. So yeah, it's basically done now. Just gonna try and document everything and give more of like a programmer's perspective on how to do PBR. I'm gonna try and explain it as much as I can, and also link to references that I've used. But yeah, I'm happy with it. So this is basically, yeah, it's finished now. And also the code is all tidied up and cleaned. So yeah, it's not just messy thrown together anymore. So when you have a closest hit color, sRGB to linear, you operate on it and then turn it back into... Yes, that should have changed the overall color. What did we do? Oh no, but those greens... Right, okay. I know why now. It's the way it's getting colored, isn't it, with the normal? It's nothing to do with that sRGB thing. Although maybe it could have been a little bit. Maybe it's the intensity thing that happens. Yeah, those two OBBs just are different. That's just so jealous you can draw debug errors in your shaders. Must be so nice. Yeah, man, it's actually not too bad to do it. And also, I've got the same API CPU side, so these ones are actually drawn CPU, the ones that you're seeing now. But yeah, they could be done in shaders as well, exactly the same. It actually wasn't too bad to add in. It's not anything special to my shading, my shader compiler. You can do the exact same thing in HLSL, GLSL. There's nothing special about it. Just takes maybe a 3 days, 2 days, 3 days of development, probably. Yeah. So I highly recommend doing that. Yeah, I guess. So let me remove the intensity and just see what. Trying to see these colors. Why are these two greens not the same? And why is that a black edge? So when you go against an OOBB, you're gonna hit. There's depth, color, normal, and we're not messing up the. We're not messing up the color here in any way based on the normal. So we just, they must all be here. So I didn't change anything. Oh, intensity. Oh, sorry, intensity is set still here. Right. So we're doing nothing now. What do we get? Right, so they all show up the same sort of color. So we do need that normal. It does help us. Maybe these borders maybe we can give these proper normals as well. Could be a thing that we do. Let's figure it out. Yeah, so there's basically a ordered ABB in it, this one. So where's the normal? Sorry, where's the border? Yeah, this is the border thingy. T. So the normal is calculated by thinking it's an actual box. This is where you could just draw a bunch of boxes that represent the edges of the bordered box. Instead of doing it this way. This is cheaper though. Yeah, you could just put boxes. And that could just produce a better. So you could just take the half dims, if you will. Yeah, you'd have to do some different offsets as well. Yeah, that's definitely a way to do it. I don't know if there's a way to change the normal in here though. So if you got your ray. The box inside the box. Yeah, I don't know if there's anything we can do to change this based on border thickness in any way. Yeah, so the easiest way to get a proper normal is to really just do it a few times and get rid of it being bordered in the actual ray tracer. It's possible. Yeah, I can't be bothered to do it, not gonna lie. So I guess we'll just live with the differences in colors. That's fine. So let's just pick good colors and then we'll just move on. So this is the cube map. We probably want to say, yeah, this is the. So what colors can we do? We do need more colors. Have a bit of a think about what colors we can do. Get colors for like an orange. Thank you, Anna. Thank you, thank you. Hey, Raf, how's it going? I mean, gonna be maybe more than a couple of days for me. It's had the ability to magically spawn geometry in a fixed function rasterizer pipeline. Oh. What are you using? Fixed function. Use an OpenGL. You can still do an OpenGL. But yeah. Or I see like a nice orange. Orange. Orange color hex. Right, so 0050. Sorry, A5. 00A5 FF. So we have to do it backwards because that's just the way it works in memory. So orange. Just get a nice pink. I think we all know what pink is, right? Pink would be somewhere about here. So a nice pink is, I think it's FF00FF, right? So it's red and blue all the way on. Well, it depends which pink you want. That's a nice soft pink though, isn't it? But I guess if you want like a Barbie pink, I think that's what you get with this one, like a hot pink. I don't know anymore. No, that's magenta, isn't it? Yeah, that's magenta. Okay. Right, I see now. Let's do this one then, because the internet says so. Right, so red, C0 for green, CB for blue. Cool. What's the next sort of color we might want? So we already got like magenta in that, right? Yellow, green, yellow. Right. Orange, yellow, green. Like a standard blue. You call that like a lime or something, you know? So maybe we want like a lime. BF, red. There you go. Like a turquoise. Turquoise. Blue. Turquoise. What a name. Right, so red is 40. Green is E0. And D0 for blue. Alright, so then a bit of cyan. And teal, somewhere around here. It's cyan then teal. Yeah. Then, I guess, magenta. Maybe get a nice violet. And then I think that's all the colors we could probably want as some debug colors. So, violet, violet. So 8F on the red. Nice. There we go. So now we've got a bunch of like different colors at least we can use in this diagram. So let's have a bit of fun. Right, so we've got that box. We've got a pixel color. Let's get all the colors up so I can just see. It's just HSL but multiple targets. It's just like I can never really spawn an arrow from, say, like a fragment shader. I have to replace it with a compute shader and do like a direct dispatch or something. I'm stuck with that in colors for my debugging. Yeah, Yeah. Yeah, as Cranston's saying, you can just atomically append. I did a VOD where we implemented, sorry, I did a stream, and it's on the VOD channel, where we implemented the debug and draw. I did it in 3 streams, I think. There was a 2D and a 3D one. And maybe it is in 2 streams. But yeah, we just look for like debug, drawing. There you go, debug drawing, part 1, part 2, and that's doing the, so I think I started with the 3D one. So the way it works is you just atomically append to a buffer, and then at the end of the frame, you just ray trace all the shapes in that buffer. It's quite simple, but it's obviously not the fastest. If you want to do it faster, you have to do some sort of acceleration structure or something, but it doesn't matter because it's just debugging. If you want it to go faster, you can do that though. But it's a very simple implementation. When I go to draw 3D, I can just quickly show you draw 3D vector. All we do is we take that position, vector, thickness, color, and Z testing, and we just allocate 9 words. A word is a 32-bit integer. So we literally just say there's a global. Oh wait. This one's in the ain't right. There's a CPU side and GPU version. We atomically add to some globally accessible count. So you could just use another buffer somewhere which stores the number of the maximum number of words. If we overflow, then we just don't do anything. But yeah, then we write into there the header. The header contains Z test and the number of words. And then basically, yeah, if we fail to insert, just return, don't put anything in the buffer. But then we write into the buffer. We transform into view space because everything is in view space when we ray trace inside this debug draw. So world to view space. Then we OR into the header the fact that it is a vector type, and then we put all of its parameters. We'll cast them. We'll do like a reinterpret cast from a float into an integer, so they just get stored in there without changing how the bit pattern is. And we just store them in there like that. And then we just accumulate a big array of all of these draw commands essentially. And then we just dispatch. Then in this compute shader per pixel, we're going over every single thing. Per pixel, we're going over every single thing we're trying to draw, and we test against it. This is where it's slow, but it's fine because it's just debugging, and we just read the bits out one by one, and reconstruct the position in view space and the vector in view space, and then just do a ray trace against it. So it's all kind of simple to do. Yeah, you just have to then write like capsule versus ray and cone versus ray. But they're available on the internet. But yeah, I have a VOD. Like, you can see me doing it in just a couple of streams, really. So, highly recommend. What colors would we like to do? And hey there, Cranston, how you doing? So, the box. I'm feeling a nice. I don't know now. For a box, I was feeling like a teal. I feel like lime could be a bit too bright. Maybe they're all gonna be a bit too bright because I've just picked. Let's see what an ugly blue looks like. Man, they're ugly. They're ugly. Let's go back to teal. Although teal wasn't shown up as kind of teal looking, it was kind of a bit bright. shown up, it really does look like cyan. Basically no change. It's very similar. Yeah, they're clearly different things. Teal's just a bit darker, it's nicer. Hey Chandu, how's it going? How you been? I guess is that normalized? Could it just be buggering up by not being normalized? What sign of that? You'll just get one face anyway, yeah. It's not gonna be... So intensity... Oh, is that dot product? Yeah, ABS of dot. Yeah. So that'd be 0 to 1. Let's not apply the intensity. Does it look teal-like? There we go. Oh, that looks better. That's more like teal, but... So what is that intensity? That just feels like really crazy big. So dot products will always give you... Wait. Yeah. So let's do that thing where we say, you know what, we just need a nice function that literally just says we can do something like this. Where is GFX global? Where's that declared? Right, here we go. We just need a boolean to say is mouse over. Or yes, the input parameter would be like your pixel location or coordinate. Is mouse at, and I guess you can have is mouse over, where you can have a bit of a radius or something maybe. Yeah, all I want is this for now, but I've been missing something like this, so I can just do something like global. I've got the mouse position globally accessible. So then you just want to say if that is if any equal just save me typing that out all the time, you know. So go back to where we were. Some of the bottom. So I can add say is mouse at so I think SV dispatch index xy. Did I do float? I did deny, I meant new. Right. So now here I can do a bit of print. I want to print out the intensity. What's going on here? Where's there a float? You a float? Why is it a float? Right, I'm not sure what pass me did there, but pass me decided to make mouse position a float. Maybe it's just more useful that way. But anyway, now we can debug print. Right, intensity is 5. So you see I'm hovering over there, it's 5. Here it's 0. Maybe around 0.1. So, interesting. That is around 0 as well. That is actually 0. That's something 0.3. 5. Weird. So with this, we can then continue to dissect what's going on. So I want to debug print a few of these boys and girls. Light in what direction? It's probably something to do with this one. Hmm? Hey Glorissa, how's it going? Yeah man, PBR is looking awesome. Super happy. Got like 2 lights working now. 100% more lights. Boom. Awesome. Yeah, not doing bad, Chandu, yeah. Not doing bad. Just been busy, you know. Doing good. Knackered. I just got back from the 13-hour shift at this non-tech part-time job. Ouch. Munching pizza and watching GP programming though, so as well. Awesome. Very cool. Hopefully you got some more time off before your next shift. Yeah, 13 hours is long. Ooh. You think some window managers have sub-pixel positions? Huh. I've never seen that. Talk to mining publications and write a book called See Vulkan in Action and sell it to me. I don't know. Problem is, doing a book on Vulkan is probably going to be terrible. Because Vulkan is so complicated, you're probably not going to help anyone who wants to read your book. Basically. Oh, this is insanely bright. Ooh. That looks... How fast is this running? I don't know. Fast enough. It doesn't... Yeah. We've not really done any... Yeah, it doesn't really matter right now. Right now I'm trying to find a good graphical art style, although I have been testing out speed when I did tons of spheres. It was okay. We're probably going to rewrite the renderer anyway and go back to BVH based ray tracing. Right now we're not doing that. And that will probably be the one we choose. This point animation unit, so okay. Doing some simple SIMD intrinsics research. Cool. Nice. Yeah, SIMD is pretty cool. You can do some really, really awesome stuff with it. But yeah, the problem with it is the programming interface. Like, basically shader programming is like SIMD programming. Like, Pi, thank you so much for sub. 33 months. Ooh, long time now, isn't it? How you been? Thank you so much for supporting me all this time. How you been? Have you seen my spheres? Look at these spheres. Oh no. Oh yeah, bit of PBR. Plastic spheres, metal spheres. Plastic. Yeah, fully rough, not so rough. Zoom. Awesome GDC talk about fast collision detection using SIMD. It was fantastic. Nice. Yeah. You can achieve, like, I think I saw someone on Twitter say, like, basically SIMD is like having, you know, you can think of it as having as like multiple threads, multi-threaded programming in a sense on a single core, just because you're able to do like so many more things at once. Although it's not obviously going to be, if you're just crunching on data, it's going to be much better. But yeah, you can write quite a lot of, you can write quite slow SIMD code if you're not careful as well. So like the thing that's really great about shaders is it basically does the SIMD thing for you. Everything runs in lockstep, right? 32 threads at a time. And the way it's implemented under the hood is each thread is, well, lane in a wave is a component in that vector register. So, and I think, there's that Intel compiler, ICC, I think it's called. Intel C compiler. I think it's this one. I think it's this one. It might be another one. But they basically have a way to, you can program like shaders. And it will then compile your code into SIMD. I guess you can call it like a wave compiler if you wanted to. But yeah. Yeah, there's a way to essentially just compile normal looking C code into SIMD, where it's essentially like shader programming in a way. But it's 8 wide instead of 32 wide, I think. Or maybe 16 now. But yeah. Anyway, stuff to look into, because that's another thing you can have a bit of fun with. Oh yeah, it is super bad without intrinsics. Do you want a tip on that one? Yes. If you're doing the Intel, so the Intel SSE intrinsics. So the way that what I figured out. So I think one of the common ones, if you want to do is a broadcast, right? So you look at broadcast, and you're like, right, I want to broadcast a hey there, Wedgilla, how you doing? How's it going? Wait, I haven't seen these before. Which one was it? Broadcast? I forgot what it was now. No. What was it before? Yeah, so effectively there's a broadcast where is it? Let's go to the SSE ones, the old ones. Here you go. I guess I saw them. Okay, maybe a bit of AVX as well. Some of these don't map to instructions. That's what I'm saying. If they don't map to instructions, don't use them, because Clang is going to do its best and implement it with instructions, and it doesn't do it good until you turn the optimizations on. The ones that are one-to-one mappings to instructions, yeah, this is it. If it says instruction sequence, then you're buggered, because without optimizations. Always use the ones which map to a single instruction. I don't know why there's no broadcast here with that's not sequence. They should show up. There is one, I forgot what it is. But yeah, that's what I got when I was trying some SMD. Give that a go and see what happens. Doing good, got some weird stuff happening in my projection matrix. I haven't noticed till now. I'm gonna sort that out. Fair play. Even ones that map exactly pretty bad, damn it. Inline assembly. There's always a way to go as far as I can tell, damn it. That's quite bad, isn't it? It's quite bad. Wow. Yeah, that sucks. I guess the other way is to... Yeah, or maybe inline assembly is the way. Right, so what sort of color we getting? -8? On the Y? -8. So if I go around here... I'm getting like a 2, whatever. -7. Right, closest hit normal. So that normal is not normalized. So hopefully... still -8. Why is it -8? It's just normalized. Right. There's a transform. So it's normalized, but... So there will probably be some scaling on that. So I need to just renormalize it. Yeah, so I only really want to rotate it. But yeah, there's better ways to do that. But it's debug code, so it doesn't really matter so much. There we go. We're getting colors now, which kind of make sense. So now they map to this sort of key on the right. Ding. So those vectors. Made up color. Right. Cool. Right, so teal for the box, because it's not really important. We'll do a nice colorful green for the pixel. Arrow for the vector. For the surface norm. For the normal. And then we'll do... Right, so teal for the box. Should we bring it in a bit or leave it there? It's fine there, I think. So teal for the box. We've got the normal. That's red. We've got the pixel that we're writing to. Pixel. That we're writing to. And then we also have this sort of like... yeah, we want to describe these sort of arrows. So I guess we can say white. They are white is the sample vectors, right? There we go. So I think that's all the... There we go. So there's our key. So there's the normal, the sample vectors are all white. I'm going to get rid of the coloring. I can just mention that detail. The colors saying how much they are. Sehr good. Sehr good. There we go. So it's got a bunch of Yeah, so sample vectors. I think that will do. Right, so that's how you calculate that irradiance map thing. I wonder if I want to change those names, because I call it like a pre-filter. Right, I think let's do one more diagram and then I might change their names. So this is how you calculate that diffuse map. So it's essentially going irradiance map, this one. I calculate this. So for each pixel, it's drawing a vector to it from the center of the cube and then launching a bunch of rays over the hemisphere and sampling all the other locations on the cube and on the higher resolution cube, and then averaging it and storing the result in there, and you get this. And this is what we use to get the ambient color as well as the so the ambient diffuse color of the yeah, that's fine, of the spheres. So essentially it's when you shear rate the sphere, wait, yeah, you get the surface normal, and you'll look up at that in the cube map and just pull out that from that low resolution texture, the cached result of this. Okay, I'm going to explain that way better when we do the video, but that's the basic idea. So the other one is for the specular, the reflect. This is the next one we want to do. So when you sort of shoot a ray at the sphere and you reflect it off the sphere based on the normal, and then you sample the cube map and you get the reflection. But the rougher it is, the blurrier it gets. So there's it's called a pre-filter map. I think I want to change the name, but this is MIP 0. But as you go up the MIPs, it gets blurrier and blurrier. Yeah, and you essentially just sample from the higher and higher MIP. So basically we want to do another diagram for this. This is the pre-filter map as it's called right now. So I just want to grab that code and bring it in. Just got to get it. Pre-filter map. So there's a few things about it. It requires some extra two functions. So there is 5 standardized dynamic length vectors. Yeah, I think it's similar to the ARM one from what I remember hearing. So RISC-V, you can write SIMD and not have to worry about register sizes. Unix will just use whatever the biggest register CPU supports in theory. Right, that's kind of cool. Yeah, I think they standardize on a way of using the same instruction for all these different vector operations, which is pretty cool. I'm not sure exactly dynamic though, because I don't know how that would be possible if you say, you know, hey, load 1,000 wide vector register from memory and then do some adds on it, you know, multipliers, and then chuck it back in memory. I feel like that would be impossible, so I don't think it is that. I think it's more of like, if you want to do a 32 wide or a 64 wide one, maybe they use a very similar instruction or the same instruction. Because I don't know how they would do it dynamically. It just feels like a nightmare. Yeah, they're moving it from the stack, basically. But yeah, I think Glorious, you know, the Clang compiler. There's a if you do a compiler these days, you always put your variables on the stack. You never put them in registers. So you always move them from the stack into registers, do an operation, then put them back. Because code gen is super easy that way. And then they run an optimization called reg to mem, or mem to reg. Yeah, they run a mem to reg optimization on it. So I think this one is on. You just have to run this pass, and it might fix. You might be able to do a very quick optimization pass, maybe, and not have to have all the other optimizations which slow your compile times down. So I think you just have to run that pass in the Clang compiler. I don't know if you can do that, or maybe it's just O1. Maybe there's a way to do it individually. More than they need for that. Oh, okay. Right, then there's probably redundancy as well. Yeah, you've probably got a lot of useless copies, isn't it? I see. That's cool. Thank you. Hey, Master Agent, how you doing? Welcome. Right, so just going to copy these Hammersley and important sample and GGX into CPU code, and then we're going to we're just adding to the mess. Completely fine, because after we're done with PBR, we'll probably restart this file anyway and get rid of all the mess, all the stuff we don't need. That's cool. So basically we need to go over all, based on the number of samples. Yeah, that's quite a lot. 1,000. Yeah, we could probably reduce that number a bit. Yeah, right, okay. So I think we can reuse a lot of stuff. Where is it? Right. So I think. Right. So first of all, let's start on 1. Up. Right. Okay. So all this code needs to be replaced. All right. So let's get in there. So number of samples. Let's do a smaller number. Let's do 128, or maybe just 64. So for every sample, we go over and do this thing here, roughness. We can use the tweakable value that we've got in the UI above, so that's just material.roughness. Yeah, good. So that will go into there. GGX Trowbridge, right, so we need to get that from the shader as well. Right. So, wait, do we? What is PDF used for? Is to choose the MIP level. Yeah, I guess that might be nice to visualize. Yeah, you know, I'm gonna leave it in because I want to visualize that. And see, but I might get rid of it when we. Yeah. So MIP level. Cool. So let's go ahead now and put in all those lovely vectors. I don't really care about any sort of weights or pre-filled color at the end of it. I just want to draw what this does. So we're going to draw some vectors world space. The sample vector, good point, what the hell was that? L. So L, we'll do it in white. And then we want to draw the pixel location it's going to be written into, and with a box as well. So it's the same sort of one. Whereas hopefully this doesn't blow up. A radical, so radical inverse. Need that as well. Sweet. So this is the specular one. So as we increase the roughness, it decrease roughness, increase roughness. Oh yeah. That's cool. So we can use, so yeah, it'll sample from the outer, cube map, and then store it in there. Yeah. Does someone know that all default matches? Oh, is it actually the latest? Interesting. Yeah, I think SSE has been out for a good while now. Because AVX, yeah, AVX and AVX2 are really popular now. Sorry, AVX is really popular now. Hey, Proton Fig, doing well, man, doing well. Yeah, just trying to build a bunch of diagrams for the VOD that I'm going to be making. Which is a VOD, the devlog I'm going to be making, which is basically commenting on this PBR work we've been doing. So yeah, just been doing a bit of PBR. Zoom. So just trying to do some nice diagrams describing what some of the shaders do. How have you been? What have you been up to? So I think I want to visualize what that MIP thing does. So I think I'm going to change the arrow size based on MIP. Or maybe should I do the color? Yeah, if I multiply it, it's a bit sketchy. Yeah, if I multiply it by maybe that will give us something decent looking. Alright, that didn't really scale nicely, of course, because red is in the lower. Yeah, so is Brave doing anything with that engine these days? Well, it's Brave if you know, if well, I guess it's Brave if you do it full time. But also not, yeah, not really. I think, you know, the engine work isn't necessarily massively hard. Right. Typically the game is the hardest bit because the game is something you don't know about. Whereas if you've been writing engines for a long enough time, I think a lot of the engine stuff is kind of just kind of similar, right? I guess you can copy paste bits and remove things and but yeah, I don't know. But yeah, I think for me it's just quite quite good. This is just a side project, so there's no real no stresses. You finished your intro project. It was based on my software rasterizer and grout shaded triangle rasterizer. Right, on 30-year-old hardware from pre-GPU era. Nice. Yeah. So grout shading is the vertex interpolation. Wait, no, without vertex interpolation, isn't it? I think, from what I remember. That's cool. I remember did you show me this before? Oh, you only posted this 10 days ago. I guess this just gives me similar vibes to other things I've seen. But yeah, this is definitely different. I haven't seen this yet. Very nice. Very impressive. Did you hand code this in assembly or something? Nice. All the way it fits them together. Oh my days. So I just see the end. So you got some fractal. You got some sort of like, yeah, I guess that's the grout shading stuff. Maybe. $3,100 surfaces. Yeah, you can kind of make him out a bit. Yeah, I can see the quads. Nice. Very cool. Neat. Well done. How did you program that in assembly or was it C? I have no idea about old school stuff like that. Before my time. Assembly. Wow. Bananas. What CPU was it? What assembler? Yeah, I want to visualize that MIP thing. Maybe we could do the size based on MIP. MIP level +1. Camel case. Right, so we can see. Right, so I guess it's the closer they are to the. See, they're all sampling from a very high MIP level. Oh yeah, because I did the min thing, wasn't it? Yeah, I did this min thing. They have to at least start at MIP 6. Yeah, whoops. I did this because I wanted a certain look. Right, let's see that. Oh, okay, they're actually quite high when you move the roughness up as well. Hang on a minute. Right. Yeah, maybe something's off with this. Code that calculates it. Hmm. But yeah, I guess we can just. It's just. But I guess there's something to think about in the future, maybe. If we go this cube map route. Nothing I'm too fussed about right now. Because I like the look I've achieved. Right, so this is a good enough thing, right? There's the null vector, the sample vector is the pixel of the cube map. So I guess I could probably rename that cube map to something else. Like the yeah, so we should probably give these some different names. So the irradiance map, that's what it's called, is the irradiance map. But I don't know why that's in there. Do we even... Alright. Not that one. I didn't put the environment map in there, did I? Whoops. Cool. Right, so that'll still work. Right, yes, I want to change that name. Irradiance map, pre-fill map. Or maybe I can just do that in the cleanup. Hmm. Then we sample from that pre-filter map. Yeah, I guess we'll leave it. We'll leave those names in. So I should probably change it where it says cube map. Pre-fill map, we'll just call it that because that's what other people call it. But I think later on in my own code I probably want to change it. Right. So those are two diagrams done. The next diagram I want to do is something like describing probably the roughness PBR. Let's find that. Let's find the one. So I don't ever want to do this, but maybe a diagram like this. And we increase the roughness, and we see like yeah, I don't know. Yeah, maybe something like this, right, where we see 68OX. Huh. Right. Okay. Never heard of it. SSC 3.5 is not supported without a flag. Oh, so it's SSC 2 then, only. Okay, fair play. By default. Did I edit this shader and it's kept my changes? I don't think it has. Right, yeah, anyway, so I want to basically probably do something like this. We have a surface, we have some, maybe some ray from the camera or something. And then we want to have, we probably want to show like some arrows to say what is specular and what is considered as dielectric. So I guess let's just start doing something, and then we can always, yeah. So let's go ahead and put this one at the start, because this is one of the diagrams I want to show at the start of the video. So I think, so yeah, we can get rid of all this complication now. We don't really have a cube anymore. Like a cube for a cube map. But we're gonna have, so we want to have something for that plane at the bottom. So we do the view from world thing over B. Then we'll have like, I guess we'll do like a plane dims. So we'll probably say, it's 5 by 5. By probably, wait, 5 by 1 by 5. Then plane dims. It doesn't have a border, so put infinity. And we'll give it 2 again, I guess, right? So that'll be the floor. We probably also want to have a sample pixel location as well, I think. So you have your sort of maybe like a pixel dims, I don't know. So that'd be probably just do 1, 1, 1, and maybe like a 0.1 here. So that should sit on top. So maybe we give it a bit of a 0.1 on the Y or something, 0.01 on the Y. Then, and we'll give that a different color. Oh, shoot. Give that a different color. So let's just give that green as a bit of an example. And then I probably want to have a camera as well, but let's just see that and see how that comes out. Right, so there's our plane, and our pixel is nowhere to be seen. My pixel, no. Right, so the plane is a bit chunky. But yeah, we need to probably move it. Plane, pause, pause. Right. So let's go ahead and not see the plane for a minute and just see if we see the pixel. Right, the pixel is there. It does exist. Oh, I need to remove that debug code. Is mouse at? There you go. Just printing stuff in the terminal if not. Right, so we get a nice little, like, little very small brick, like a very half brick of Lego, or 1/8 brick of Lego, or that little slab they have in Lego. So I think we need to probably, so maybe the position of, yeah, so we need to really bring them down to probably a -1 position wise. This can probably be -0.5 maybe. 0.9 maybe. Let's try that. Right, it's clearly not down enough, is it? So let's move it. Wait, these are half dims. Isn't that right? Half dims. Whoopsie. Right, so now that makes a lot more sense. It's actually like a size of 2 or something. Okay. Right, so given it's half dims, uh, 0.5. Huh. I guess just raise it a little bit more. Oh no, the position is a center position. So it's -1, 0.5, so I'll put it at 0. Okay. So if we start that off at -2, it needs to go lower anyway. Just put it at -5. This one needs to be 3. Or maybe just 4. So that we should be able to see something there. Perfect. So here's our plane. Here's our sample position. It's off the ground a bit and we could see that. Even without shadow. Oh, okay, 4.5. Ding. So I think we actually want to have the floor a bit higher. Because I probably want to have a way of drawing some rays that reflect inside it. But not all the time. But yeah, so let's say, let's make it probably move up to about 3 and 2. Alright, let's give that a go. Alright, that's good. So there's our sample point. We can make this a bit thicker now. So if we make it a bit thicker, let's make it, I guess, 4 times as thick. So that means we need to move. Oh, how many times down does that go? So yeah, it's got a 4. I think it's 5. I think it will be back on 5 actually. Right, I think that's correct. No. $4.5, I think. Okay, so that sits on top there, nice. I'm expecting to see some different sort of shades, but how those shades get calculated? It's a dot product with the light direction. Right. Okay. Right, it's an ABS though, so it lights both sides. Alright. Yeah, I did it for a reason. Anyway, let's just leave it there. Okay, so now we've got that plane and the that little sample pixel position. We probably want to have a camera up here or something looking down, and we'll have a ray that goes pew, and it hits there. But I think we're going to have a ray that goes down and hits there. And then I probably want to have so let's get the camera. So what shapes do we have? So the camera can be it could be a sphere, I guess. Or it could just be a vector facing the wrong way. Yeah, let's do that. So we do a vector that faces the wrong way. So I have a camera position. So the camera is going to be like probably something like that. Just up to the right. No Z though. Then you would need to be able to. There's a pixel position. That's cool. You want a vector towards the surface. So I guess we can call this the ray. Yeah, let's call it the ray. So the ray is going to be a subtract towards the pixel from the camera. And then you probably want like a direction, which is just going to be a normalized version of that. Then you need the inverse for that camera. So vector in world space. There's a camera position. Then we want the vector that represents. We want it to point the wrong way, and it's going to be a very small vector. So probably then scale it down by something like 0.1. And then give it a thickness of like, I don't know. Where's the color? Vector thickness. Oh wait, okay, it's cool, it's cool. No transform. Alright. Hey hip hop master, how's it going? So that should represent the camera. It needs to be red. Maybe red, maybe orange. Or an orange camera. Maybe. Where's my camera? Oh, it's somewhere I can see a spec. I see my camera. It's so small. Okay. Let's make it a bit thicker. Let's see if that makes it bigger. Still there. So I think we changed some of the code. So yeah, we changed some of the code to the sizing of the vectors is kind of nice now, and it doesn't leave just a cap. So Do we need to add like a new one just called cone? Because yeah, basically I want like a cone. I could just put a sphere there instead, to be honest. Sphere in world space, camera position, done. Radius of 1, maybe. Where did I learn this? I don't know, lots of places, lots of trial and error. Right, 2 is clearly not enough. You got anything specific that you want to pick up on, and I can send you in a direction? Right, so what's too big? Also, how do you ever then just work on this consistently when you have a programming job? I don't know, I just really want to do it. Basically. Yeah, I just really want to work on it, and I just think it'll be cool, right? I get satisfaction from working on my own stuff, and I feel like it's got many benefits. You know, potentially it could be made into something in the future. It could help me with my career progression. What else could it do? I also want to try and have something where other people can learn from as well. That's another aim. So I guess it just ticks a few boxes, and I just get excited about doing it. Yeah, I think that's about it. It also gives me a way to, like, you know, when you work for someone else, you have to program, like, in a way where, you don't program in the way that is fully expressive of you, right? You always have to change the way you program because you're working in a different environment, working with other people, and so when you work on your own little thing, you can spend as much time on doing certain things, or that you wouldn't necessarily be able to do in a job environment. Yeah, that's another factor too. Do I speak Russian? No. No way. I'm English. So UK. So yeah, I don't really know any languages. I did German at school. So I know a bit of German, but it's very basic. Ich bin Henry. Uh, ist. Das ist gut. Yes. Wunderbar. Wunderbar. That's all my German. I find it hard to go back and forth between my own style and other people's style on groups. Fair play. Yeah, I don't know. I don't think I had that problem. I guess it depends how often you work on your own stuff. I think the biggest thing is if you work on your own project, you need to make sure you put enough time in. If you just do it once a week, it's very easy to come back and have just forgotten everything, and you don't know what you was doing. And so there needs to be some level of momentum that you carry through. Or you need a way to really remember quickly, so when you get back in or get back working on it, you can, go a bit quicker. What else? Or maybe another thing is to do is have a bit of, if you can't necessarily program all the time, a big part of programming is thinking. So maybe you can think, you have a spare moment to think outside of work, but you can't program. So you maybe write down something or have a think about what you want to do next. And that way, perhaps it helps you retain some of that memory. Yeah. potentially. Right, I think I want to move everything a bit closer. It's just too far out away, you know? Maybe we can zoom the camera in a bit, to be honest. Yeah, that shouldn't mess anything up. Where's that camera? Because we hard coded it. United States rendering software engineer without a degree. Yeah, I don't have a degree. I kind of started doing one and then I bailed because it was just a load of crap. Unfortunately. I did a local one. And it was not great. Right, minus 20. Let's do minus 15. Let's see where we are there. Bit better. Maybe that's alright. Given the other one. What's that switch? Let's go to the other diagram. Right, now we're a bit, So maybe, you know what? We just need to make everything a little bit bigger here. That's the problemo. So increase that by 1. Let's try that out. Maybe the size was alright. I just need to bring it closer. So let's say minus 2. Alright, I lost that pixel thing. Yeah, let's say minus 5. Alright, that's much better. Camera's there. Where's this, Oh yeah, I made it 5, didn't I? Wait a minute, what did I do? Yeah, 3 instead of 2, that was it. So, yeah, it's looking a bit big, that box. Right, there we go, much better. Can I get a bit closer? Maybe that's okay. So let's draw the ray now. Easy peasy. So vector world space. From the camera position, we're going to draw a ray. And we're going to draw thickness, color. Color is going to be red, I think. Well, I like red for the surface normal. Maybe we could draw a bit of a line. Then, should we do the surface normal? So at pixel position, we can draw an up vector. 0, 1, 0. We can change the thickness to be something sensible. Let's just get it in there and see how it looks. Rightio. Okay, so it's clearly a bit too big there. Thickness wise, it's humongous. Now it's way too small. And I think we actually want to move them a little bit away from their... Yeah, so I guess you're on a pixel to the right. Cone. So I guess I can also subtract or molest a little bit, right? 0.9 on that. Bring that back a bit. Maybe make it a bit thicker, I'm not sure. Ah. Yeah, so we've got our ray going down there. It hits here. Here's our surface normal. And then, right, so what do I want to describe from here? So there's quite a few different ones. I think... So we could do like the reflect ray, I guess. We can then say there's a diffuse, or the reflect ray. There's the diffuse, which will come from everywhere. And then you want to probably talk about the specular as well, based on the roughness. We probably need a light in here. And yeah, because I wonder what I want this there's probably a few diagrams which are going to look like this in a way. So I need to figure out what they are exactly. Right, I'm just going to take a quick 2-minute break, get another drink, and then we'll have a think about what the diagrams need to be exactly. I know I probably want to have something like this where we show we increase the roughness and it changes maybe the shape of... Yeah, maybe that's a different one, like a microfacet diagram. Maybe that's what we start off with. But yeah, we need something like yeah, I'll think about it. Right, BRB. Alright, welcome back. How's it going? Food on summer Phil, getting better at cooking these days. When I need, this. Awesome. What meal was that? Oh, big tea burgers, awesome. Yeah, stone rebels is the jam. Right, so I think I need to list out all my diagrams that I want. So I want a diagram. I probably need a diagram where it talks about this microfacet thing and how, you know what, it needs to really be built into. Yeah. Yeah, so we probably want that, and I'm gonna show like a rivet. Yeah, yeah. That would be quite easy to do, I think. Um, right, let's quickly write this out. Okay, so we'll do them in the order that we want. So on like a microfacet diagram, how do you just spell this thing? Eh. Microfacets, there we go. So on a microfacet diagram, we want, so, yeah, we talk about how there's roughness, and that will change. And you probably have like a pixel, and is a certain size, and all of this is not simulated through code. Specifically, it's more expressed. It's more simulated through maths expressions. Well, it's like an estimate, isn't it? Estimate through maths expressions. Basically. So I don't really have to have the rays, I guess, in that diagram, but I could always do them. The next diagram needs to be something like you have a camera, you have a surface, and you probably want to show that. Let's go to the PBR code. So, so reach light. Yes, in PBR there's that diffuse component and then there's a specular component, right? Wait, let me find that. Okay, 2 seconds. I just need to go through not screen only, secret screen. Bum bum bum, but I'm still here. I need to go through some messages, private messages. I want to keep. There's a link I want to get. Right, I got the link. We're back. So basically, what's the rendering equation? An equation in which defines the outgoing radiance for a given point at a viewing direction v. Where v is our viewing angle, where v is our viewing angle, BRDF, so that's the specular component, is a bidirectional, no it isn't. Yeah, it's a bidirectional reflectance distribution function, BRDF. And L is the radiance incident on point P from direction L. So direction of the light. Yeah, so n is the normal vector and P normal vector at point P, and then the hemisphere is aligned to n. Normal says the hemisphere. H is the halfway vector between L and V. And a bunch of French fries made from fresh potato. Oh, cool. Homemade chips. Yes, the UK way in it. Chips. The hemisphere is aligned to N and H is halfway vector. Right. I've omitted N. Yes, this is only enough for one light though. I guess, wait, unless that's... Yeah, this is same for everything over the hemisphere, isn't it? Yeah. For everything over the hemisphere, do this. I've made N and H as function arguments, but in reality they used to develop the BLDF. Right. Yes, the BLDF has a specular and the diffuse. Right. So I wonder how much I should diagram, or what diagrams I should do. So that's like a specular reflectance when these two are... Yeah, this is like a good angle for specular reflectance, basically. Whereas diffuse is just... Have a look at that one again. Yeah, diffuse will still be based off the view dot half as well. Yeah, right. Yeah, this is the inverse of... You apply just the... Yeah, the albedo based on... If you don't want any... So if we view the diffuse, when you turn metal up, you don't get any diffuse. Yes. That is because... Where's metal used in here again? Yeah, that's because... Right. Yeah, so I wonder... Good question. Do you get function definitions with C? Or is that not a thing that everyone... Or is that not a thing and everyone just man's X? I'm not sure what you mean, Puka. Do you mean like... What? Oh, do you mean like the standard library and things? Yeah, I typically don't use too much of the standard library, but when I do, man is a good place to look. Um, yeah, man is a good place. Um, the other one is just if you try and Google for it, that's another one. But I typically don't use the standard library too much. I more use like the platform stuff where possible, and have my own layer on top of the platform. But you will have to use some of the standard library. We'll get that built into the IDE. Yeah, if you use like a language server protocol, you get it. Maybe not. Should do though. So I guess I want to make another diagram like this, where you have like some. Yes, you're like diffuse, which comes from. Yes, the diffuse is like it bounces around. Right. Okay. I guess I can. So if a light comes from up here, say, and it shoots down, it will bounce around within the material and then reflect back out, and it just happens to go back this way, if you will. So that's what you're simulating. Of how much of it goes into the material and reflects out. So that's what I kind of want to show. But obviously we're going the other way around because the way we render is go this way. But maybe where specular is reflected. Specular is reflected. Yes. Is more of like a perfectly reflected. Okay. Yeah. So I guess what we could show is like a bunch of rays reflecting that way. And then for diffuse, and as you increase the roughness, see if you just turn off, if go and view diffuse, and then you just make it really rough. That doesn't really affect the diffuse, does it? Not really. Okay. Yeah, it doesn't really affect it. Cool. So, so when it bounces around, happens, comes back that way. Has normal mode K, which executes keyword program. Oh. Interesting, never knew that. That's cool. There's so much stuff in Vim that most people don't know. We're learning Great Britain English in Swedish school. This slips into my code usually, like I have a ton of colors with a U, and they're named some value underscore color. But then all the Unreal's code base is, yeah, American English, isn't it? Yeah. Couleur. Yeah, I just use American spelling, even though I'm English. I just use American spelling because coding, like, you know, programming is typically, it is American, right? Typically. So I just roll with that. But at work, because we're an English company, is like proper English. Hey there, I don't know what to tell you. What to tell to. I'm just run a PBR render at the moment. We're doing some diagrams about what is PBR. What tools am I using? NeoVim, Vulkan, C, and a custom C compiler I've got as well, which compiles C code to shaders, or SPIV for shader programming. So yeah, that's what we. That's everything there. Right, so I think the specular one's quite easy to do. I guess that'll be 3. So 2 would be diffuse. What is diffuse? What is diffuse? What are microfacets? Right, just 3. What is specular? Right. So we kind of want diagrams like that. I'm struggling to think how I would do the diffuse one, but it should be possible. We need to somehow describe as well that we're tracing the other way around. And then, you know, hmm. Yeah, you can't really do it in Python because it's just too slow. But also, Python's like doesn't scale well. It's hard to know what type is what in Python. But you could probably do it in Python. It'll just be really slow. But yeah, I wouldn't do it in Python. Thank you, appreciate it. What is specular? So after we've done, you know, maybe we can do the microfacet diagram quickly. Let's just start on that one. So we'll save that other diagram for when we do the diffuse and specular one. So microfacet, we basically want to draw more of a, so draw a bunch of flat, a bunch of flat rectangles. It's quite easy, I reckon. Little boxes, we'll just draw them. So you want to say like, hey, how many? You want to say how many? Let's just say the steps. Let's say there's 20 steps. Now I want to know how many. Step dims, maybe? Half dims. We could probably make them like 0.5 all around. Just do that, see what happens. And then, yeah, we'll have a pixel size in that, right? So, you know, maybe we might do a camera as well. Have a think about it. But yeah, so then we need like a for loop. So rather than drawing this plane, we'll do a for loop. steps, and we're gonna work out. So we need to have like our start position, or step position, if you will. So I guess we can just start that off at like steps divided by 2. Then you probably want to negate that result, and then yeah, probably multiply it by the half dims dot x, probably times by 2 again, and I guess we can just set 0 and 0 there on. Okay, so as we go, we're just going to increase the x by step half dims multiplied by 2 along the x. And I think in here we're just going to put in the step position and the step half dims. So that's cool. So I guess as we yeah, so let's just see, we should see a floor basically, and then a pixel being drawn on top of it, I think. Right, so there's our floor. It's broken into 20 steps. We just can't see yet because there's no angle. We're still seeing this though. So I think I want to make the half dim a bit. On the Y, probably 0.2, maybe a bit less. So, okay. So there's that, and then as it gets rougher, maybe do 2. So I guess as it gets rougher, you want like to rotate the, have a matrix, or a transform 3D, as we call it. We need to probably have an odd even setup. Yeah, so you probably have like your, just call them, I call it T, I guess, do 2 of them. By default, they're both initialized to this. But I guess if you have some form of roughness, we then want to rotate them a little bit. So I guess we can always do a mole rotate. Yeah. So you want to have some kind of like, right, so you just say T index mod 2. Yeah. So yeah, you probably want to use that. There's a way to do a rotation. P rotation. Yes, on a rotation along an X. Wait. On a rotate it like that. So it'd be like a Z. Yeah, Z1. Z. So based on the number of radians. So roughness 0 to 1. I guess we could just throw roughness in there, give that a go. And then obviously we've got the negative one, and that'll just be negative that. Yeah, I think that'll be alright. So yeah, we might go the wrong way around, but let's just put it in. So multiply transform 3D. You want to rotate in view space or world space? Probably in world space. I have no idea. Right, let's give that a go and see what happens. Right, so we clearly rotated that a bit wrong, but I see they're broken in different segments. Though, little slabs. So I think I got these the wrong way around. So we rotate in view space. Applies after. I need to have a way of thinking about that. Got a question from a person working at Epic. If I had an idea to handle their chunk fragments, the ECS mass more effectively, as it now just checks the remaining. What? All right, maybe I've done no, so it happens the same way. I need to translate it back to origin. No. I need to think about that. More effectively, as it just checks the remaining time on each chunk and ticks even interval has been reached. Otherwise, decrement down the interval. After replaying with the proposed solution on pastebin, after looking at code related to the chunk handling, I realized that the engine does this for all actors, and that my proposed idea being extrapolated for all actors should be significantly speed up. Efficient in worlds with many actors. In my solution, ensure my solution was sorting tick groups into buckets based on the tick interval and calling the full group if we had a bucket for a given tick. This by turning the float tick interval into a scaled up integer and then use as an ID to find the tick group. Right. Nice. So you just solved the yeah, you just stopped it from accessing all the entities basically, and just cool, pretty sweet. Like, do you have any numbers? What the gain is? Yeah, I don't know why these are. I want them to be in the same place, so they need to be rotated around origin and then moved out. But I thought that's what this would have done. So from world. Oh shoot. I just realized. Right. So you've got to get it into view space. So this is its local space. So it should be before like that, and that should just work. But it appears to be the same. So what am I doing wrong? There is a position, unfortunately. Step pause. So that is the problem. What we need to do is apply locally right, I think we can call this like R or something. And then basically we want to do that multiply. Computer T. Mul transform. So you need that view from world. And this is where your local space stuff goes. So you need to actually multiply. You want to translate first and then, sorry, rotate first and translate. So I think we want to say transform 3 or translation, put in the step position, and then put in the R, that rotation, and then here goes in, T goes in there. So that should be it. Wait, step position, we'll just do 0. So it allows you to offset it even more. But yeah, we'll just keep it as 0. Right, should be what we need. There we go, look at that. Oh, as we decrease the roughness, increase roughness, boom. So so the one thing that we're missing is we don't have a little arch. We could have sub steps that put another one and it's just flat always, right? And it's just elevated based on sine or cosine maybe. But yeah, it shouldn't be too, or elevated or, yeah, whatever. So you could say for every one that's, I guess you could just draw another one, and you would draw it like halfway, and it'll just be smaller. Without any translating. You could draw it completely straight. Now the dims of that, what would you call it? It's like a little let's call it step 2. Screw it. It's a smaller piece. So this one is going to be, it's not going to be as, so that's the x axis. We probably want to say 0.1, maybe even smaller. And then the depth is fine. Height is probably alright as well. So we'll drop that in here like that. So the amount you step then is probably just a half dim every time. And that should, the thing is you're not getting the height offset correct. So the height, you'll need to add, the height will probably be, is it sine or cosine? No, it wouldn't even be any of those, I don't think. Maybe you just put in material roughness. And we'll just multiply it by some number. But you'll need to know, you need to copy the sign based on some, based on, well, there's no sign, is there? But you want to make it negative if let's Let's do something like that, should be alright. So I think, oh, compile error. Ooh. Let's try that out. So do we put the little, right, so we've got the little smaller step there. It's a bit vertical and it just went the wrong way around. So that's pretty close, right? We're happy with that. It's a little bit too tall. Yeah. You know, if it's that, maybe it could be kind of square along those two axes. Maybe it's a bit too tall. No, so clearly I'm just doing a bit too much, right? So we can just simply multiply that by a bit of a smaller number, like 0.5 maybe? So let's try that out. Right, so we could probably stop the roughness about there, and then it's perfect, right? So that's a good illustration of that. So we could probably say then, as you move the roughness to this value, yeah, we could. So that would be like, when I multiply it by probably about 1 point. Oh no, sorry, yeah. So we'll call this like A, or I don't know, C or something. 0.75 I think was the sort of value we want to bring it down by. So these are just going to call C, C, C. There you go. So that should be enough to get that to work. Right, 7.5 bit too much. Let's do 6.5. And roughness. Right, 0. Where is 0.5, 0.6? Maybe should be enough. Right, 5.8 it is. So there we go. That is the microfacet sort of, oh shoot, looking floor thing. Ugh, you know, 0.5 maybe. I didn't realize it would be half. Maybe we could have brought this down a bit. But the brick. Just elevating a bit too fast. There you go. Voila. So as the surface gets rougher, yeah, just something like that. So do we want to show any sort of like rays here where if you shoot a ray against it, we probably want to show this like a pixel size as well. So we could probably say have an area. So the pixel could just be that y0, probably a bit more forward. Probably about a 1 or something. And then we'll probably give it like a half dims of 1, maybe 2. As well, same there. Yeah, so I don't really need the ray anymore. I should Alright, so maybe I need to make it a bit thicker. 3. Yeah, so maybe I need to make it a bit wider. 4 there, maybe 5. And then let's put it at like 5. Let's have some large worlds yet. For smaller numbers of actors, it'll be a bit slow because the buckets, but in cases where it'll be unpredictable because a small number of. Yeah, that makes sense. Yeah. Right, maybe we can say. Yeah, so increase your roughness. Yeah. So this is a pixel that you're shading, and we can say like, as the roughness increases, maybe we can make the pixel a bit bigger still. What else? Yeah, so this can be used to describe that microfacet thing. And so you probably want to show like, hey, I'm shooting a pixel array here. Um, um, maybe we should set up some on these specific points. And just show how they change. So as you drag the slider, it'll get rougher and maybe. Like if you put that one on that perfect point, easy enough to reflect. It's just that. Here, I guess we can always, if we put it in a certain place, the normal, we can just change the norm. We can know the surface normal and just. Yeah, I guess you can know the surface normal a bit. And probably draw another ray or something. Probably need like 3 rays and just show how. Yeah, so you probably want to have some kind of like sun or something like that when you shoot rays. They'll bounce a bit differently based on the roughness. Yeah, and then I guess in this example we can copy paste it and talk about how you shoot rays from the camera instead of from light sources typically. Yeah, that's what we'll probably do. These are the time complexities on the search buckets that I've calculated. Might have bugged it up. Best case 01 if the element are in a single bucket. Right, average case. Right, if all the buckets are the same size. Get this complexity ON. Right. I see. Right, nice. Basically it's always yeah. Most of the time it's better, if not all the time. So if you draw rays from the sun, they will be hard-coded to specific positions. Some will get a perfect reflect still, but others will get, well, you know the normal will change. So you could probably do the reflect. I guess that pixel sample could come in later. It's a bit like 1 what are microfacets, 2 what are 1 what are microfacets, 2 what are the we want to show that we want to ray trace from the camera, right? And we talk about the reasons why that happens. And then you say what is... So then everything from then on is done the opposite way around. What is diffuse light? What is specular? And then probably talk about... Yeah, then it can go from there probably more into... I wonder if we want to do another diagram like this as well. With vis-a-vis an angle, BDF, bidirectional reflectance distribution. Yeah, right. I think I need to have a bit of a think off stream exactly what we need to do after that point. Yeah, I think we can do... Next time we're going to do more diagrams, so we can finish off that one. And probably do these 3 diagrams as well. So we've already got 2 which are complete. This one's half finished. Probably get these in next time as well. And I've got to think about the ones I want to do after that. And then I'd probably just want to talk about some code and go over that as well. Right, so I think then next stream will be Thursday, 7:30 p.m. GMT +1, and then Sunday, I guess, when we'll do the recording. So we're getting there with that. There's a VOD channel if you want to watch previous VODs. Check out the previous stuff we've done. There's also a YouTube channel where I post devlogs. This is what we're working on, is the next devlog. Bit of a complicated devlog because it's a complicated subject. And then, yeah, there's also Discord if you want to come and hang out in the meantime. Right, let's find somebody to raid. TCAP is on. TCAP raid. Right. You want to add? Oh. Yeah, I've ads at the minimum on this channel because, yeah, much prefer the experience of people just being able to watch the stream. But yeah. I'll see you all in a future one. Catch you all later. Have a good Wednesday. I'll see you all Thursday.